Welcome to this evening's library talk, Trees, Moving to Greener Pastures and the Soil They Need, presented by Bob Niklevich and Phil Trombetta. Phil and Bob will cover interesting research into how trees support each other via the mycorrhizal network and explore what home gardeners can do to help trees survive. Next slide, please. Master Gardeners partners with the Napa Public Library to present our library talks. Our library representative couldn't be with us here tonight, but she sent along 2 book suggestions. If you want to learn more about mycorrhizal networks. The first is called Mycorrhizal Planet, How Symbiotic Fungi Work with Roots to Support Plant Health and Build Soil Fertility by Michael Phillips. Phillips offers an overview of fascinating scientific findings and offers practical ideas for home gardeners. The second book is Finding the Mother Tree by Suzanne Simard. Simard's perspective is that of a forester, and it examines the relationship between forest trees and the fungi that support them. Both of these books are available at Napa Public Library, as are a host of other resources to help you become a better gardener. Next slide, please. The mission of the UC Master Gardeners is to extend research-based knowledge on home horticulture, pest management, and sustainable landscape practices to California gardeners. Next slide, please. Our parent organization studies program outcomes, and to do so, it would like to send you a brief follow-up survey in a few weeks. We hope you'll take the survey, but if you prefer not to, type your name into the chat box now, and you will not be contacted. You can also type your questions for Bob and Phil into the chat box, and they'll address them at the end of tonight's presentation. With that, I'll turn things over to Bob.
Thank you for the introduction. Hello, I'm Bob Niklevich, and before Philip talks about trees that are the stars of this presentation, I would like to introduce you or reintroduce you to the supporting cast that is the fungal network. It's in the soil, helping the trees survive, that in turn help us survive too. I will present some research regarding interconnections between trees and fungi, as well as the possible ways communication is done between the two. That area is called the Wood Wide Web. I will ask if the two organisms work together or are they independent of each other. I'll start my portion with the following definition and disclaimer. Oxford English Dictionary says communication implies the imparting or exchanging of information or news. The subject of Wood Wide Web is a fungi communication has fascinated scientists and lay people alike. As such, I would like to impart to you information about the soil beneath us. We may think that communication is generally verbal or written or electronic methods, but there are other methods of doing this too. Let's start with what we perceive through our senses. But first, the disclaimer. Currently, there is a debate whether fungi communicate with plants with a purpose or they do not. Most scientific answers may not be found for decades or centuries. So just like global cooling or global warming, climate change debates about fungal communications will continue. To find the truth, sometimes we have to look a little deeper. All the theories we've had in the past are now have been arguments that have been for or against issues, but take time to find. So let's start our conversation from a plane's window from 36,000 feet. What do you see? Well, from 36,000 feet, there's not much to see. It's fairly indistinguishable. You can be flying over a forest like this and just see green blobs. But as you get closer, there's more detail to see. Things you may not have imagined start to appear. They start to look familiar because you've probably seen them before. You're familiar with shapes and you understand what you're looking at, so it makes it easier to understand. From fairly close range, they become easy to recognize. However, sometimes the human eye cannot see things clearly until they're much closer and recognize what they're looking at. So once on the ground, you start seeing more detail, really incredible. The more you can see, the closer you are, The things that you recognize makes things more understandable. What was a blur from far, far away becomes clearer, and you start to recognize things. Things that you have seen before and understand to a certain extent make it easier to understand and to appreciate. I mean, you can look up and see the trees. These are individual life forms themselves. You can hear, you can see colors, you hear sounds of birds or rustling leaves. These are things that you have been familiar with and fairly familiar with because you've been around them so long. But there are often things that you don't know about because you never looked. How often have you looked down below? I mean, really down deep. How many of you have looked down and dug into the soil where you were standing? And if you did you know what you were looking at or what activities are really happening down there below your feet? Did you automatically think of roots? Yeah, there's a whole system of roots, but also the bacteria and fungi below the system is called the mycelium. The roots are not everything there to see. If you're looking down deep, you realize that mycelium is mixed in between the roots. The roots them, and then the mycelium is even smaller. They're so small that the naked eye can't even see them. In 1885, they found a symbiotic relationship between plant roots and the mycorrhizal fungi. So deep inside the ground, we have the root system connected to a kingdom of the fungi. Fungi are not plants. They are a life form unto themselves. We usually do not see them except when they produce fruit. Well, the fruit of fungi is the mushrooms or truffles or puffballs, etc. They are living bodies of fungus that are called mycelium. They do not see light very often, and so therefore they function best in the darkness of the deep soil. Fungi can look like hundreds of different things, from mushrooms to the thrush in your mouth from coating your tongue. Silky threads or slime mold, these are all shapes of fungi. Now, did you know that your feet have over 200 types of fungi on them? Well, this is not exactly what we're talking about on a subject today, but I should mention that all fungi and molds are not desirable. Fungi infections of your plants, the walls of your house from water, toenails, yeast, ringworms, candida auris, these are all fungi that can affect the body in a negative way. So just be aware that they're around us all over. So here's a question for you. What do these organisms have in common? On the left side, you can see a horseshoe crab, you see shrimp, spiders, so forth, centipedes. And then on the right side are mushrooms and puffballs. So what do they have in common? No hands, okay. Well, I'll tell you. They all use chitin to build their cell walls. The hard outer shell of the arthropods and the fungi are made from the same materials. Plants do not do that. This is only organized in this kind of organism, such as the arthropods and the fungi. The mycelium is a web of tiny filaments. They're called hypha. These secrete acid and enzymes to break down organic materials to be absorbed into the roots. Mycelium is interesting in that it could be as small as a dot in the soil, or it could be hundreds of acres in size, depending on how long it's been around. The hypha mass of filaments can be a collective growth that can be almost a half mile in length over time. They grow out from the roots into the soil looking for nutrition, especially for water. You might recognize roots or even fungi on first blush. On the left photograph is just a picture of roots packed into what used to be a pot. On the right side is oyster mushroom mycelium growing over coffee grounds. These are just extra ways of finding fungi that you may not have been aware of. However, mycelium benefits the ecosystem by generating new soil that gives life to plant growth. The thing is, without the fungi, the ecosystem structures that make soil will stop. It will lead to stagnation of the system with multiple secondary problems. Primarily the dead plant matter that was normally broken down will not be broken down as such. And therefore the nutritional soil it produces stops. This stops basically all kinds of plant life in toto. Now the key to component to the function of our ecosystem is the healthy mycelium. The difference between a forest and a desert is the ability of the soil mycelium to retain moisture and the ability of the fungi to decompose organic matter into the soil. So to rephrase that a little bit, Whether it is ground cover or fully grown trees, there's a need for moisture and nutrients that the mycelium provides them. Fungi are the primary organism for disassembling decaying matter, and this is the key to the healthy soil and therefore healthy plant life, which in turn means healthy us. The system of hyphae and fungi that live inside the cortex roots connect each other, individual plants. So the hyphae of one plant will eventually grow and connect with other plants. They also transfer water, nitrogen, carbon, and other minerals. It is located between the surface and about 36 inches down. So this is a very viable piece of agriculture and products that we take for granted. If you ever dug into the soil with a shovel or plowed, we're destroying some of this fungi. So when the fungi and the plants connect, it's called a mycorrhizal network. The plant life in the forest is always being stressed by outside factors. It's just a matter of life. They're exposed to the heat, cold, bugs, drought, whatever. There's things always been challenging that network. To fight these challenges, plants have many sensors to help them manage their life cycles. So how does the mycorrhizal network seem to deal with plants, stress in the bigger picture? Well, the mycorrhizal fungi can grow 100 to 1,000 times the length of the tree root. They're very small hairs, remember, they're very almost microscopic. It's estimated that 9% of the land plants are connected by the mycorrhizal network. Think about this. A cubic centimeter, which is not very big, can contain miles of these little fibers. These fibers increase the ability to reach out to other plants and to connect and share nutrient matter. Some studies show that the mycorrhizal network in a new environment gives nutrient support to new plant seedlings. Pretty cool. Now, in an article written in Nature on August 7th, 1997 by Susan Sinnard, who was mentioned earlier on the presentation, she coined the term wood wide web. Very catchy. I kind of like that. Her research on the mycorrhizal network indicated that there are communications between plants, not only for the health of the plant, but for their safety as well. If you look at this drawing, on the right side, there's a tree indicating it's in a shadow, whereas the tree on the left is one that's in full sun. Underneath the brown, which represents the soil, we'll see the roots of the tree, but also the white filaments, which represents the fungi. The tree on the left is getting full sun. That means it's being able to absorb that energy from the sun and through photosynthesis produce sugars and carbon. The sugar and carbon now is into the soil, and the fungi absorb this for its own good because it does not get it from the sun. In exchange, it produces nutrients and push them back into the roots for the tree to survive, as well as water. The tree on the right side, with the shadows, it also has a photosynthesis ability, but in the shadows, it's not as strong. So as it comes down, it produces the sugars and carbon, and the fungi will return the favor to the shadow tree, producing, again, water, nutrients, but also carbon, which it may not get as much as because it's in the shade. Now, there are many trees that have been around for the longest amount of time. These trees are called the mother or hub trees of the forest. I'll be using the term mother tree for the rest of the talk just for the sake of time. Now, on the left photograph shows a very large tree. This would be called the mother tree because it has the deepest and most established roots, as well as the best developed mycorrhizal network. It's been proposed that they can help young seedlings survive in the shade, as well as reduce nutrients to other trees or bushes that are competing for the same resources. It is claimed that they can even distinguish the difference between their species of plants, as well as their own legacy plants, their offsprings. They can find a weak plant and send extra nutrients to it, or withhold nutrients to other non-desirable invaders through their network. Forests cover 30% of the earth. That's 1 billion trees. Forests are carbon sinks, which means they absorb carbon dioxide, which we are so concerned about now. The mycorrhizal network is a key to keeping trees in the forest healthy. Carbon is needed for the health and growth of our plants. I mean, without the plants, we're not here. The mycorrhizal network is the mechanism that can move more carbon that in turn gives more nutrients to the plants through the soil. So let's consider what's going on under the ground. Some researchers have found that for a young shaded tree, getting nutrients for growing is critical and also difficult. With less sunlight, less carbon photosynthesis occurs, which results in decreased nutrients for the plant and the trees. The mother tree pumps that sugar and carbon into the young tree's roots with access provided by the wood wide web. Trees also can communicate dangers to other trees about insects or invasion of other species of plants. They also can produce specific chemicals to deal with these invaders. Now, once attacked, the plants can produce chemicals that will repel or increase the likelihood that the soil be unfavorable for the invading species. And if the tree or the network is invaded more often, the concentration of the toxins are increased. The mother tree helps form stronger immune system for the other trees around them because of the network. This process is also found even in tomato plants, how it releases organic volatile organisms for the protection of the plants. Now here's a schematic of what a mother tree and its wood wide web may look like. So the tall tree on the left would represent the mother tree. The white lines are the communication network between the mycorrhizal network to saplings, other plant life that is favorable to the area, and or can produce contacts with undesirable species that can now be destroyed. Many trees in the immediate and some distant plants receive the benefits of that mother tree. Now, the mycorrhizal network may spread toxins produced by one tree and transfer them to competing trees to harm it. For example, the eucalyptus trees can produce the toxins that keep other trees away and stimulate other eucalyptus trees via the wood wide web. It is believed that the repellent chemicals can also be selective. However, the research has not been unanimous in these findings. By the way, do any of you like spicy food, drink coffee or smoke? Well, some of those poisonous chemicals produced by the plants are spices, caffeine, and nicotine that were originated as insecticides, which now attract people. Just saying. Now, this is an overhead diagram of the interconnections of the mother tree and her legacy plants. The wood wide web suggests that it spurred research onto this mycorrhizal network. Other scientists confirm an underground village of symbiotic relationships, connections that spread from hundreds of miles in a pristine forest. The wood wide web, in essence, is a plant marketplace. It provides supplies and communication hub to keep the plant's village informed and going. Now, if we look at the diagram on the left, there's a blue arrow pointing to one large green, dark green dot. The green dot represents the mother tree. The lighter green ones are legacy plants, and some older trees that are still connected to the mother tree. And all the black lines are indication of communication between the smaller green dots as well as some of the other medium colored dots. This is what the wood wide web would look like underground. So I'm going to go back to my first definition. Imparting or exchanging information or news is communication. A lot of scientists have been interested in this. So to test this, they did some ingenious processes. One was using carbon isotopes placed in the soil. They also had bags, large plastic bags put over branches of the trees, and they pumped in carbon isotopes to have the leaves absorb them. After a time, they were able to follow that carbon isotope via a Geiger counter back and forth through the network of mycelial fungi below the soil and into other trees in the network and up into their branches. So just by putting this carbon isotope into a tree soil and or into the leaves, it shows a communication between that one tree and the trees around it via that Geiger counter. They had gathered evidence that some of the plants may also emit and detect sounds or impulses. In particular, a crackling noise in the roots at a frequency of 220 hertz, which is inaudible to humans, yet it appears that they can be received and reacted to by other plants. Now, if you look at the picture on the right, that represents a stone falling into a water bath. It's a high-speed picture, freezing the waveforms. It hits a liquid medium and that produces a wave. Is this a form of communication? Have you dropped a pebble into the water and you've seen the waves? What are sound waves if we're listening to something in the air? Those are sound waves being transmitted through the air and our ears pick it up. So if the stone can make a wave that is analogous to a sound waves at the right frequency we can hear. So perhaps there is communication, but just at a frequency we do not hear. Here's some diagrams to represent that. The diagram on the left is a representation of what sound waves look like going through the air. The middle picture is again my picture of the root ball at the bottom of the pot, also communicating with each other. The far picture on the right are representations of a human neuron transmitting electrical impulses into the brain, into the muscles. So there's similarities between the microbial network and the first internet. From under the electron microscope, some of the researchers say the mechanism is much like that of the nervous system that's indicated on the right. So my question is this enough proof that communication occurs, or it's not enough proof? So my next question is, do plants deliberately move to greener pastures, which is kind of where we're coming with this lecture? When stressed, mother trees, their connecting trees and seedlings can provide more essential nutrients as well as deeper sources of water where needed. So again, do plants deliberately move to greener pastures? Well, in a less stressed situation, these wood wide web exchanges still occur, but the extra help they give is less crucial. Survival continues as long as the soil functions better under healthier and plentiful conditions. The fungi will expand when more growth of plants occurs and where soil conditions are good. Good meaning there's decaying soil and there's moisture to keep that wood wide web, the microbial network, healthy. So if the conditions remain dire, the microbial network could expand to more favorable conditions via spores. Survival of spores will continue when there's no more water supply and nutrients. Spore activity is an ongoing process, but moving from one location to another to a better environment is not coming solely from the underground network. It is coming from the spores. Spores are constantly being transported by wind, attached to insects or onto animals. In both the good years and bad years, this process continues. Research findings from the Columbia's Climate School finds plant species that are adapted to certain cool climate conditions are gradually moving north or to higher elevations where it's cooler. In the last several decades, many plants have moved approximately 36 feet to higher elevations or 10.5 miles to higher altitudes every decade. Arctic tree line is also moving 131 to 164 feet northward toward the pole each year. I want you to note also that fungi grow best in warm temperatures. Some species of fungi do grow better at warm temperatures, 79 degrees Fahrenheit, and even higher temperatures of 130 to 150 degrees, while some fungi can even thrive at temperatures below 32 degrees. It would appear fungi do better with warm and hot temperatures, less so in the cold. Healthy soil mycelium fungi, they work better in healthy vegetation. So, question, if fungi can live in these extreme temperatures, what would be the advantage for the fungi and the microbial network to move in the first place? Is there an advantage for fungi to move? Well, spores, like trees, they need plenty of moisture and the nutrients to produce the healthy mycelium. When an individual area starts becoming unfavorable because of drought or excessive heat or cold, will they die or will they move? Since fungi can live in temperatures extremes, and they do grow for thousands of years, how extreme does the temperature have to be for them to move? I don't know, I'm just asking. The 2,200 acres of Oregon fungi colony had trees dying. It was not stated for how long or why the die-off was happening, but was it temperature or moisture or age that caused this huge colony in Oregon to start dying off? So what do we know is that a healthy mycelium promotes healthy trees and plants. Fungi supply much of the nutrients because they're a symbiotic relationship between them and the trees. So can we say that where fungi go, trees grow? Don't answer that question. So for the home gardeners, what does it mean to you? Well, You must understand that the microbial network is damaged by fungicides, fumigants, tilling soil, and the rest of those situations that are common for us working in the yard. They are damaging to the microbial network because you're disturbing the fibers where they're growing. So obviously fungicides can kill them, but tilling the soil will also break them apart, making it harder for them to reconnect. Also digging compacted soil slow down that microbial network from expanding. So how can you keep things healthy in your yard? Well, first thing is maintain a constant layer of mulch. Mulch really helps keep the moisture in, and we know moisture keeps the soil a little more friendly to the fungi so it can expand. You can use raised flower boxes where you control the moisture more than you would on an open field. So keeping moisture and the soil loose in the plant boxes makes it easier for the mycelial network to expand. For depleted soil, microbial amendments may help. Microbial fungi do not tolerate sunlight, like I said before, and need to be deep. So when you cover the soil is needed, covering soil is needed to keep that those elements safe. The University of Minnesota Extension states microbial fungi improve nutrient uptake overall, especially in saline or drought-prone soils, and they can improve soil structure over time. So we may not need amendments often, but they are available and they do help in the right situations or the bad environments. So in summary, can these things be considered communication? Mother trees may be able to distinguish other trees from her own offsprings. The mother tree may be sending more carbon to the kin than to a stranger, or even diminish the new growth with toxic infusions of strange plants. Sound waves or electrical impulses may be received and understood by other plants via the mycorrhizal network. Mycorrhizal network expands to favorable soil when local soil conditions deteriorate. With the assistance of wind and or living carriers, the spores will be traveling. So again, are these responses that convey information in a form we simply do not understand or accept yet? Or are they nothing at all? Is there a communication network below the surface that we still have not gone to know? Do fungi and mycorrhizal network present a communication system that functions with a purpose? Or is this network just acting in a random pattern of survival without deliberate or focused goals? Are the plants and fungi moving or expanding to protect themselves from climate change? Or are they just translocating by spreading out by a wider distribution of spores while old colonies die in response to climate change? This debate on plant communication movement will surely continue into the future. So my last question to you is, what do you think? So my takeaway points to ponder for you is, when you're walking on a forest floor where you cannot see the life that lives just inches below your shoes, should you step lightly and wonder if it has always been there? Think of yourself as a tourist in a new land and culture when you're in a forest or a field. Appreciate what you do not see or totally understand that's below you. Just know that there is a whole new world for you to know, even though it has been just waiting for you for over 1 million years. Perhaps someday we will communicate with each other. Who knows? So I will now turn this over to Philip, who will continue with what is happening to trees in California. Thank you. Go for it, Phil.
Thank you, Bob. So Bob just covered very interesting. This is an example of the tree of life, and you can see the underground network of the root system. And then I'm going to cover the top of the trees for the second half of the lecture. So what's happening to our trees in California? Next slide, please. So trees need our help. What's happening to our trees? This is an example. I like this example because these are native white birch trees. And when I was a kid, you used to see a lot of white birch trees in the 60s and 70s, almost in every yard. And because of the drying and warming conditions of our environment, you're seeing less and less, and they're getting diseased and dying. Next slide, please.
Oops, my bad.
So forests and trees are dying due to many factors. If you look at this picture, it's a really interesting picture. It shows a lot of death in a forest. And I'm talking mostly about forests today, but we can transport that over to our home ornamental gardens, of course. So total tree coverage in this state has declined by 6.7% since 1985, mostly due to wildfires, drought, and logging. And according to a new study, trees are living about half as long as they formerly did. This is kind of interesting. In my research, I found that they're living half as long, but they're growing faster and quicker. Next slide, please. John Muir, this is a picture of John Muir, and I like this quote. And the reason I like this quote, going to the woods is like going home. And I'll tell you why, because I have always had a real affinity for trees ever since I was a young child. I don't know why, but I've always just really been interested in many different trees. And I feel like trees are family. My trees and shrubbery and bushes and everything in my yard, I feel like they're like my animals. They're a part of my family. So I like this quote. John Muir was a naturalist, and he was the co-founder of the Sierra Club. Next slide, please. So I'm going to talk a little bit about climate. Climate has been changing for eons, so it's nothing new. Of course, since the Industrial Revolution, it's been increasing and changing quicker. But climate change refers to long-term shifts in temperature and weather patterns. These shifts may be natural, but since the 1800s, our human activities have been suspected as being the main driver of climate change, primarily due to, of course, fossil fuels, coal, oil, and gas, which produce heat-trapping gases. This is interesting because they're talking about taking away, just this week, gas stoves in homes. And I've always been in the hotel and restaurant business for many years, and I think it's going to be very difficult for chefs not to cook with gas. So energy and manufactured materials made from fossil fuels are used in every aspect of the human life throughout the world. Just as I was saying, I think cooking's one of the biggest ones. Next slide, please. Climate change acceleration threatens trees. So climate change is the biggest conservation challenge facing our Forest Service. In the 21st century, and contributing to the global efforts that help forests migrate and adapt to climate change is a priority of the Forest Service. In the late 20th century, the focus was to allow fires to burn themselves out if it didn't endanger life or structures. Unprecedented drought for the last 4 years have put tremendous stress on our trees in California. The results are widespread tree mortality. This last 3 weeks of rain have been wonderful, but I hope it's not over. I hope we're going to get more, because I was just speaking with someone and I said, well, I guess our wells are all full. And they were saying, no, what I've been reading is it's going to take 4 years of this to fill up our underground water systems and our wells. With the current increase of rain, so much rain can also cause waterlogged roots and can damage trees if trees sit in water. So it's kind of a give and take. Next slide, please. So I'm going to talk a little about photosynthesis, and Bob touched on this earlier. So photosynthesis has to do with the top of the tree and the root system, the bottom of the tree. Photosynthesis is the process by which trees turn sunlight into, like Bob was saying, food, which is carbon and sugar, and to help feed the tree. If trees do not have enough water, this process is interrupted. So when trees are not getting enough water, the food is not being created, and growth stops and death occurs. So lack of water and nutrients or sudden loss of water can also create air bubbles. So this is interesting. What's happening is the lack of water, the root system, the structure of the root system is still trying to get water and nutrients out of the ground, even during drought, but it's sucking up like air bubbles, and they're called embolisms. And these embolisms within the tree transport up into the tree xylem and create air bubbles. And that's when you see like the tops of, or the tops and sides of trees starting to die off. So the tree has then a hydraulic failure and cannot transport the nutrients from the roots to the leaves, causing them to dry out and die. This can also cause the death of young growth in branches and treetops. Next slide, please. Here's a perfect example. There's a white birch tree with the top of the tree dying off, and you can see the bottom still looks fairly healthy, but the top is drying off, and that's how trees die. They dry from the top down. So and then of course when the trees die, they become more susceptible to bark beetle and different types of predators. So our current prolonged drought has weakened a great number of trees, increasing the number of successful beetle attacks. When birch trees become stressed, and I'm using birch trees as an example, but all trees basically become stressed, they become vulnerable to insects called the bronze birch borer. The first symptoms of an infestation are the yellowing, light pale green leaves, sparse, stunted foliage, the upper crown progressing to twig and branch dieback. Trees may decline for several years before dying, although hot and dry conditions will definitely increase the rate of dying. Next slide, please. So what different kinds of changes have been observed? So there's a white birch tree that's completely dead right there. You can see the evergreens around it and the birch tree, and it's completely gone. Then the insects are bark beetles and borers. Bark beetles attack the exterior of the bark. The borers go inside the tree. Interesting thing with borers, I have a Chinese pistachio in my yard, and you have to treat the borers systematically through the root system and up. And that's what I'm doing. I'm trying to save this tree because the Chinese pistachio has such beautiful color in the fall, almost like a fire red. So, and then on the right picture right here is a really good example of canopy death, and you can see the top dying, and even some of the sides of the branching out on the sides does not look very well. Next slide, please. So signs of trouble. If you have trees in your yard and signs of trouble, all trees have an average lifespan. In my research, the lifespan of a birch tree is anywhere between 60 and 80 years. Oak trees, hundreds of years, 300 years, redwood trees, thousands of years. So all trees do have a lifespan, but some do die too early. Signs that a tree may be dying are many, and they differ greatly. One common sign is a lack of leaves, so sparse growth, loss of top canopy, or an unusual color change, a loss of green color in the leaves, dull yellowed brown leaves on all or part of the tree are indications that all is not well. Other signs of a dying or drought-stressed tree may include bark and branches becoming very brittle and falling off. This is something that actually I've observed during these rainstorms. And if you drive on these country roads here in Napa, you'll see a lot of branches that are on our roads, and they're falling off from the wind and the rain, and those are stressed out, brittle and dried branches that are falling off. The tree trunk can become spongy or brittle, or a little from too much water. That's what I'm talking about with our roads here. And diseased or dying trees may have mushrooms growing out of the base or along the trunk of the dead internal tree tissue. Okay, next slide, please. Here's a couple of pictures of some trees that are not doing very well. These trees on the left are in Berkeley, California, London plane trees, and you can see they look terrible. They're planted as street trees. We actually have London plane trees here in Napa around Fuller Park on Jefferson Street. And so you can see the loss of the leaves in the canopy. These are not healthy trees due to prolonged drought. And then the tree on the right is a oak, and that is not doing very well either. It's all brown. That's a sign of from drought. Next slide, please. So as Bob was talking earlier during the presentation, do trees actually move to greener pastures? Everything moves. Everything has moved for, well, since the beginning of time, everything moves. So migrations of plants and animals. So all organisms have moved since the earth began. Some move quicker than others. Active migration is commonly seen in animals, including bird, fish, insects, as they move from one area to another. Migration is a form of adaptation to the physical conditions and changes. So plants and fungi passively migrate when seeds or spores are blown and carried away. And the rate of the future climate change is likely to exceed the migration rate of most plants. So the climate's changing quicker than these plants can actually move, plants and animals. Next slide, please. This is just a little slide that I put on there to kind of show you that of course humans were moving first, followed by well, humans and animals, elk and deer, and then insects are moving, and then lastly, very slowly, of course, are plants which do move. Next slide, please. So further changes for plants and trees. The replacement of dominant plant species by locally rare species may require decades. Extinctions may occur when plant species cannot migrate fast enough to escape the consequences of the climate change. Increasing temperatures have brought about earlier bloom times for plants, creating a potential for a mismatch between pollinators and plants. And this is something that's being observed a lot in the last 15, 20 years. So bloom times are changing. As a matter of fact, I found it really strange. I just saw a week ago, I saw a tree full of white blooms, and I took a picture of it. I was just so shocked during those rainstorms that there was a tree in bloom. So this mismatch between pollinators and plants could reduce plant seed production. Pathogens, pests are also pathogens and pests are also often more selective in warmer temperatures and when plants and heat are heat stressed. Not more selective, but more active. They're much more active during heat. Next slide, please. So where do we find the right places, the right trees to replace those that are failing? So if we look at other Mediterranean climates with latitudes that are similar to California, we can find trees to replace the ones that are dying and not doing well here now. So if we look to like the West Coast, starting down in Mexico and Southern California, San Diego, Los Angeles, that area, some of the trees that are doing really well right now down in that area, we could potentially bring up here, and hopefully they'll do well here. And then our trees, of course, are going to move up the West Coast to Oregon and Washington. So Mediterranean climates have specific regional features, and the features are hot and dry summers, and cool and wet winters, and generally, but not always, a hilly landscape. And I think this year we're going to experience a true Mediterranean climate with the hot summer and our cool and wet winters. Mediterranean type ecosystems, MTEs, with their characteristic and unique climate regimes occur in just 5. This is really interesting. There's only 5 regions of the world that have Mediterranean type ecosystems. Next slide, please. And here they are. So we have, of course, California, the West Coast, Oregon, southern part of Washington down into Mexico. And then we have central Chile. And this is interesting because if you think about it, a lot of grapes grow in these certain areas, right? Then we have the Mediterranean basin, which is Spain, France, Italy, and then the southwest part of Australia, and then a little bit of an area in South Africa. So what are the trees we have now? Will they adapt to our new climate? And how can we help them? Next slide, please. Mediterranean climate trees and some examples. So this is a really great example and picture of a manzanita. Evergreen trees. Some of the trees we have now are bay laurel trees. That's a native California tree, pine and cypress trees, this manzanita, madrone trees, and of course our famous California coast live oak. Deciduous trees, we have sycamore on the riverbanks, valley oak trees, the beautiful valley oak trees that we have here in California, and then California buckeye, and some olive trees, fig trees, walnut trees, and vines, clematis, and grapevines. Next slide, please.
Not working here, Bill.
Uh-oh.
Is that it?
That's it. Okay, I think so, yeah. So some ways that plants and trees protect themselves against heat and exposure are, if you look at these drawings, they're really neat. I can't see the bottom of it, but so thicker leaves, they have thicker leaves, they have a hairy, a waxy, or succulent plants. I know that our California coastal live oaks have the curled leaf, and that helps them with sun exposure and drier heat climates to help reduce the surface area. Waxy, a lot of tree leaves will have a waxy coating on them, or almost like a hairy or furry coating on them. Some of the succulents, those are ways that leaves can help to protect the plant and tree from heat. Next slide, please. So what can we do in our home gardens with native and ornamental trees and shrubs to help diminishing forests? And there is an example right there of a beautiful olive tree, which we have, of course, many olive trees in Napa and Sonoma counties. So take appropriate care of our current trees. So taking care of our trees, mulching around them, giving them the appropriate amount of water during very dry summers. Also, we can create microclimates in our yards. I have some beautiful Japanese maples in my yard, and they look great all the way up until September because they're shaded partially by the hot afternoon sun from some 60-year-old redwood trees. And so by creating a microclimate where they're getting sun in the morning and then some shade in the mid to late afternoon when the sun is the hottest, that helps those trees to look good. There's a lot of trees, a lot of Japanese maples that are in full sun all day long, and they do tend to burn here in Northern California. So that's a current way of taking appropriate care of trees. And then replant dead trees or removed trees and shrubs with ones that are adapted to our changing climate. That's where I'm saying maybe looking to other Mediterranean climates for some different trees that we can bring here to Napa and Northern California to replant some of the trees that are not making it, like our poor white birch trees. Next slide, please. So looking to the future for replacing trees that die with better choices. So look to places that are currently hotter and drier than what we are here. So different areas, and what could be successful here? That's a question I put out to you. Maybe doing a little research on your own and looking at what maybe some trees that could be successful here. And there is ongoing research going on with the UC system to study lots of research, I'm sure, going on to study climate and adaptation for future landscape trees. And the next slide is going to show you. Next slide, please. This is an interesting UC study on climate adaptation for landscape and tree choices. And it's pretty simple to look at this. And this is showing, so Berkeley and Eureka. And this is showing a 10-year compare tree species composition of the example cities in the climate zones of California to species composition cities that are currently as warm as the example cities will be in 2100. So in about, what is that, like we're 20, so like 70 years, 60, 70 years, the temperature here in Berkeley, or I'm sorry, in Eureka will be similar to the temperature of Berkeley. Or wait a minute, Berkeley will be similar to the temperature of Eureka. So it's changing. We're going to be about 10 degrees warmer here. And of course, then Eureka is going to be 10 degrees warmer. It's just moving up in just 70 years. Next slide, please. So what can we do to help our trees? Well, give your big trees a big hug. You can see, keep your soil, as Bob was talking earlier, keep your soil healthy, mulched. Don't over-till or over-process your soil. You don't want to mess up the microbial network. We want to keep that all intact. Take care of what you already have. So take care of the trees that you have. Make sure to give them a little bit of water in the summertime, a few times during the summer, even established trees. Replant trees looking to the future. So look to the future on, as you know, maybe trees that are going to do better, like the last slide just showed, in warmer temperatures, 10 degrees warmer. And choose carefully and consider water needs of trees and plants. And then, as I was talking earlier, create protected microclimates. So you can create protected microclimates or even plant smaller trees or shrubs on certain areas of your home that have a little more protection, you know, in the mid to late afternoon. And then love your trees. Okay. I think I'm turning it over to Lonnie now as the next slide. And Lonnie will, Lonnie's going to cover this, our references, and wrap it up and go over upcoming events. Lonnie, are you there?
Hi, Phil, this is Jane. I'm taking the place of Lonnie right now. Thank you, though.
Okay.
Thanks, Bob and Phil. That was really interesting. I always learn something new from our library talks. We did just see a quick reference slide back there. There you go. There's a list of all the references that were used this evening for this evening's presentation, and that will be available on our website, the UC Master Gardener website, and I'll touch a little bit more on that in just a second. But we also want to touch on some other upcoming events that will be offered in January. Actually, we have moved past some of those. The pruning fruit trees did have to be canceled due to that rain that weekend, and that will be rescheduled. We just finished our winter rose care pruning workshop, as well as a hands-on pruning session at Fuller Park on the 19th. Coming up at our Las Flores Learning Garden at the end of this month on the 28th, we'll have their garden ergonomics, using tools the right way. And Bob Niklevich, who is a presenter this evening, will also be presenting that. There is limited space, so be sure to go on our website and sign up and register. And then our garden talk next, our library talk next month, that's coming up, that's February 2nd. Love Your Rose Garden. We're going to be talking a little bit more about roses. We're almost at the end of the ability to get bare root roses, but there's other ways to think about adding roses to your garden. So that's an upcoming event. Next slide, please. And where can you find this information? You can find it at our UC Master Gardeners of Napa County website. That's ucanr.edu. Next slide, please. And here is a photo showing you where you go to our website, the UC Master Gardeners website, and then scroll down past, up at the top, there is the events, find us, and then you can scroll down and see past programs and events. And on that one, you can see all of the website, all of the various programs, both food forum, workshops, and library talks that we've offered over the past couple years. So I hope you'll visit that. You know, and we talked a little bit this evening about the health of trees, and don't forget that we have a help desk, and you can also find information about our help desk and contact our help desk about symptoms that you may be seeing on your trees or other plants and you want a diagnosis. Next slide, please. Okay, we're going to open it up for questions now. Thank you. Thanks for joining this evening.